So we have demoed that how you can use the peak technology to process the input data sets. And this is just for demo. We already illustrated in previous slides that in practical case, the large commercial company will use this technology to process large-scale data sets. And if you then have some experience for this kind of technology, that will be helpful for you to seek a job in industry. Here's the peak learning Kmeans hands-on. I'm not sure how many what's the time I left, but I can go through that quickly. So it will show big Kmeans. I will just run the program quickly. Local Kmeans. This is Kmeans. We already show the code. So this time the difference is that this program is get run iteratively. That's the difference. Oh, we lack of UDF. So we need to copy. Where's the UDF? I'm sorry, UDF, the user-defined function jar file is not in the sandbox. So we cannot use a function to find the centroid cluster for specific observation. This part is missing. I will send you the point after the presentation. So we'll go through the slides. This, if the program gets executed successfully, we will get this kind of output results. It's a centroid of Kmeans output results. So Selena makes some introduction about the HBase. Earlier, Jerome makes some introduction about Hadoop. And earlier, Professor Chada makes some basic introduction about MapReduce technology. And so we are talking about covered many MapReduce technology in today's session. And what's the motivation? So the motivation is that we are in a big data area. The rapid growth of information in science will lead to the significant increase in information, which require significant computation power to process these data sets. And fortunately, with the development of MapReduce technology, we can solve this kind of issue. This issue is called a big data issue. There is a book named Fourth Paradigm, the computation technology. And today we covered how to use the MapReduce technology to solve the big data issue. And we even build a search engine system on top of that, use Hadoop, HBase, and the peak technology. And this search engine system is just for demo. But even for this demo, we indexed 656,000 web pages from the core web data sets. It's an academic web page data set. And we calculated the page rank value for about 2 million web pages. This is the architecture of the search engine system using the MapReduce technologies. There are 3 layers. The first layer is the presentation layer. There is some web page that you can have some input and you get some output. It's similar to Google. And the second layer is the business logic layer. Basically, it is just a set of PHP scripts, Hive or peak statements. And it can be used to describe the business logic of the search queries. Like if you have multiple queries you will have the and or or operation, and you can use these scripts to describe that. And the third layer is the data layer. This layer is basically built on top of HBase. HBase is on Hadoop and HDFS. We use the HBase to build inverted indices for large set of documents. Building inverted indices require huge amount of investment in both software and hardware. Previously, only few companies can afford this kind of technology, but now we can use the MapReduce technology to do that. This is the PageRank code. Then we can make a live demo for this system. We go inside the system. This is introduction. And this is a GUI for Indiana. We search Indiana. We get some web pages. Then we check one of them. We come to the appropriate one. I cannot find the search key. Common, which one? Okay. Thank you. Indiana. Yeah, it's here. So, because this kind of information is already indexed in HBase table. And here is the ranking value. We already calculated the site value. Yeah. That's the whole demos for the peak part. And as you know, the earliest search engine system is built by Stanford in the 1990s. And I'm not sure whether it's the first search engine system built on top of HBase, but it is the early try. And we demoed this because we want to show the students how to use the MapReduce technology to solve the big data challenge in the near future. And if you learn this technology, that could be helpful when you seek an opening in the industry. This is basically my part. So any questions, I would be glad to take.